Hello everyone. This video is about last year fall semester 2019 exam 1. For the multiple choice question, the first one we can see from here we are going to use the Square Theorem, and we know sin of 2x is less than or equal to 1, greater than or equal to negative 1, and then divided by 7x is the same, divided by 7x, and then limit x approaches infinity. Similar, we have to add the limit x approaches infinity and limit x approaches infinity. So we know this term is 0 as x approaches infinity, and then similar, this term is also 0. By using the Square Theorem, we know the middle term is also 0. So that is why we have B. And for the second question, find all solutions. That means we may have more than one solution. And then on the interval 0 to 2 pi, we know the right side square root of x is just the square root of pi is just the pi to the 1/2 power. So we know the power must be the same. That means we are trying to solve for the equation. What is the value of x? That cosine of x is 1/2. So for this one, you can just use the unit circle. We know cosine of 60 degrees, that is pi over 3 is 1/2. Then similar, we can find another solution that is 5 pi over 3. So you can see this is cosine of x. And for the second equation, 1 is equal to 1/2. We have two intersections. That means we have two solutions on the interval 0 to 2 pi. For number 3 is similar to one of the in-class activity. We can rewrite this term. Square root of x is just x to the 1/2 power. And then x squared, 2 is in the denominator, 3 is in the denominator. So this one. And then for the derivative, you can see 2 multiplied by 1/2 multiplied by x to the minus 1/2 power. So the first term here, we have x, you can see 2 can be cancelled. We have x to the minus 1/2 power. X to the minus nth power is equal to 1 over x to the nth power. So that is 1 over x to the 1/2 power. And the x to the 1/2 power is just the square root of x. So the first term is just the 1 over square root of x, and similar, the second term is this one. So we choose C. And for the next one, for the arctangent of x, this is the function graph, arctangent of x. That is just the inverse of the tangent of x. Then we know when x approaches infinity, the arctangent of x goes to pi over 2, and similar, the other direction is negative pi over 2. So this is a sine function, is a continuous function. Arctangent of x is also a continuous function, so we can take it inside. That means the limit is equal to sine of limit x approaches infinity, this one. And then we know the inside one, arctangent of x when x approaches infinity is just pi over 2. So the inside one is just the sine 1 over 2 multiplied by pi over 2, which is sine of pi. And we know for the function, sine of pi is just pi over 2 is sine of pi over 4. So sine of pi over 4 is the square root of 2 divided by 2, which is B. And for the next one, this one is equivalent to which expression? So natural log base b, x to the x power, b to the 2x power. This one is equal to natural log b, x to the x power plus natural log b to the b 2x power. So we know this one, x is the power, we can pull it out. So this is equal to x multiplied by natural log base b x power. Then plus, so this question is asking what is the value square such that b to the squared power is b to the 2x power. So we know the second part is just a 2 square. 2x. Oh, there's a typo here. The equation is, oh no, it's not a typo. So we choose, based on this one, we choose A. Number 6, For number 6, we are given these 4 conditions and ask you A, B, C, D, which one of the functions satisfy the following 4 conditions at the same time. So you can see the third one is easier. F0 is 1, so we can check it one by one. F0 when x is 0 is 1. 0 is 1. Arctangent is 0. This is arctangent of x. Then when x is 0, it's not 0. So we know it is not D. And the cosine of 0 is 1. So we check this one. And then the next one, the first one, the domain of the function is all real numbers. That's true. The second one, for all x, we have the function must be positive. The first one is must be positive. And for this one, for the second one, the function graph e to the x power. This is the function graph, so you can see it's positive. But for the third one, cosine of x, the function graph is this is an oscillating function, so you can see it's not positive all the time. We have the negative value, so C is not correct. Then we have one more condition to check, that is the last one. Given 2 functions, A is less than B, then the function is increasing, so that means f of A is less than f of B. So we can see for the first one, x squared plus 1. This is the function graph. So you can see this part shows you the function is now monitor increasing. So we have to choose B. And for the next one, number 7. Number 7, this is equal to f prime of 5 because f plus g prime. Prime of 5 is equal to f prime of 5 plus g prime of 5. So this one is equal to minus 3g prime of 5. Then we are given the values. So it is D. Next one, IVT. We are given the function f of x is guaranteed to have a root which is 0 on which of the interval. So we know for the IVT, the condition is we have to check first close the interval, suppose A and B, and the corresponding value f of B must be positive or negative. If f of B is positive, then f of A must be negative. If f of B is negative, then f of A must be positive. They must have different signs. So let's see. For the first interval, f of 0 is sine of 0 plus cosine of 0, which is 0 plus cosine of 0 is 1. So it is 1. So this side is positive. And f of 2 pi is sine of 2 pi, which is 0, plus cosine of 2 pi. So cosine of 2 pi is positive 1. It's also positive. So you can see the first term is not correct because they have the same sign. Then we have to check the second one. F of pi is sine of pi plus cosine of pi. So you can check it by yourself. By using the same method, then you can see actually D works. So I'm not going to show you all the details. If you have any questions about this one, just send me an email, then I'm going to show you. So the next one is asking, what is the sine of theta? If we are given that x is equal to 5 multiplied by secant of theta, and we know secant of theta is just 1 over cosine of theta. So now we know x is equal to 5 multiplied by 1 over cosine of theta. Then by this one, we can multiply by cosine theta on both sides. Then we have this one, 5 over x. So we know sine square of theta plus the cosine square of theta is 1. So the question is, what is the sine of theta? If we know cosine of theta is 5 over x. So for that one, we know cosine square of theta is 5 squared, which is 25 divided by x squared. So now we know this is 25 divided by x squared. So for the sine square of theta is 1 minus this one. 1 minus this one is which is x squared 1 minus this one. So x squared minus 25. That is sine theta, and by this one, we know it is just the square root of which is c. We can pull it out. That is just x squared minus 25 divided by x, so which is c. And for the next one, number 10. For number 10, which type of discontinuity? So for this one, a removable discontinuity will occur at x is equal to c when limit x approaches c, f of x exists but is not equal to f of c. So this is from the slides. Removable discontinuity. So you can see removable discontinuity. Let's check it first. When x is equal to 0, that is numerator is 0, denominator is 0 plus 0. So this is the 0 divided by 0 case. That means the function f of 0 is not defined. It's not defined. So let's check the limiting value. Let's check if it exists. So limit x approaches 0 plus x cosine x multiplied by e to the x plus 2x. And we check if they are equal to the theorem minus case. Okay, so you can see here in the numerator and the denominator we have a common letter, that is x. So this term itself is just equal to limit x approaches 0 plus cosine of x divided by e to the x plus 2. So this one, if you can just plug in x is 0, then we have 1. 0 plus is just 1 plus 2. Which is 1/3. And similar for this side, it is 0 minus cosine x divided by e to the x power plus 2, which is also 1/3. So we can see the left side limit and the right side limit, they are equal to each other. So this one is true, exists, but it's not equal to f of c because f of 0 is not defined. So for this one, we choose A. And the next one, 11, at x is equal to 1. This is x equal to 1. The function graph below is, you can see this function is a continuous function because we have no holes. It's not removable, infinite jump, none of them above. So we know this function is continuous. But the function at this point is not differentiable because of sharp corner. This is a sharp corner. That is one of the examples that the function is not differentiable. So for this one, we choose B. And for number 12, which condition, what is the value of x or which condition on A and B that this piecewise function is continuous at 1? So continuous at 1, let's see, the left side limit that means we have to use the first part. As x is equal to 1 is A minus B. And the right side limit x approaches 1 plus f of x, we have to use this one. That is 3. So in order to make it continuous, the left side limit A minus B must be equal to the right side limit. So that is C. A value is this one. So this one is just the limit x approaches 2. The numerator is x plus 2, x minus 2. Denominator is x minus x minus 6, excuse me, x plus 6, x minus 2. Okay, so we can see that x minus 2 can be cancelled. X approaches 2, x plus 2, x plus 6, which is 4, 12, 1/3. Okay? 4, 8, excuse me, 4, 8, which is 1 half. So that is A. Number 14. Evaluate the limit special point 2. So that means this one means the slope of the tangent line at point 2. The line, this is the tangent line. So you can just plug in x is 2. When x is 2, it is equal to minus 6 plus 8. That is 2. Oh, excuse me, I'm sorry. This is the slope. Slope of the tangent line. This is the tangent line. So the slope of the tangent line is actually the derivative. And the slope of the tangent line is negative 3. So this one is equal to negative 3, which is A. For the question 15 is one of the example in class. I made a mistake in this question. So for this one, we are given two function graph f and g. So the question is asking, what is the f prime of 2? F prime of 2, we know this is the point 2. F prime of 2, this is f. This is the f. So f prime of 2, the tangent line of a linear function is just itself. So this is the tangent line. That means they have the same value. So we have to look for the slope of this blue line. So you can see this is the first point, this is the second point, 0, 1, and the second point is 3, 2. So the slope, the slope of this one is 2 minus 1 divided by 3 minus 0, which is 1/3. So this is f prime of 2, which is 1/3. And the second one, g prime of 2, g prime, the right function is g. So if you try to draw a horizontal line, this is the horizontal line, then you can see, excuse me, if you try to draw a tangent line at this point, you can see it is horizontal, so that means the derivative is 0. So it is 1/2 plus 0, which is square root of 1/3. So square root of 1/3 is just equal to this one, C. Or if you cannot see why they are equal to each other, you can just because this is the square root of 3 divided by square root of 9, which is square root of 3 over 9. That is square root of 1/3. And for the free response, I'm gonna just use the solution. Then that is easier. So the first one, nominator, you can see when you plug in pi over 2, you can see this is sine pi over 2 is 1. This is a 0 divided by 0 case. And we can see the nominator is square root of something minus something. So we are going to use the trick multiply by the conjugate. So if we multiply by the conjugate of this one, it's the square root of x, square root of sine of x plus 1. So you can see for the nominator, we have only sine of x minus 1 left. Then this term can be cancelled. Then we are done. And for the second question, it's pretty similar to the in-class activity. The first term and the second term. So first term is just 1, and the second term is just e to the x, which is 1. So please pay attention. You have to keep the limit until you use the information x approaches infinity, like this one. And for this term, for this one, we have to divide it by the highest power of the denominator, which is 4. So we divide it by t over 4. So the denominator, when you divide it by t over 4, or in other words, multiply by 1 over t. And then similar for the denominator multiplied by 1 over t to the fourth power, then we have this term. So you can see when t approaches infinity, approaches 0, approaches 0, approaches 0, but the denominator, this term is non-zero, so the function is defined, so it is 0. And then for this question, k approaches 0 plus. So this is 0 plus. The denominator, you can just plug in 0, which is 1. And for the denominator, 2 to the kth power is just 2 to the kth power. And the 0 plus is this side. So it is 1 minus something greater than 1, because it is right here. It is from this side. So it is a little bit bigger than 1. So 1 minus something that is bigger than 1, it is negative. So we have negative infinity. And for this one, so you can see, use the limit definition of the derivative to find the derivative. That means you cannot use L'Hopital's rule. You have to use the definition. The definition is just x plus h minus f of x divided by the difference, which is h. So you just do it one by one. F of x plus h is 1 over x plus h. F of x is 1 over 1 over 1 plus x. So we have this term, and then just keep working on it. Then we have this term. And just ignore number 3. This is from section 2.7, which will not be tested this semester. Number 4, find the equation of the normal line. Pay attention. This is the normal line, not the tangent line. So for this one, first we have to find the f prime of 1/2. We know f prime of x is e to the x power. So that means the slope of the tangent line is f prime of 1/2, which is e to the 1/2 power. That is the square root of e. So the normal line, we have to use minus 1 divided by that one, which is this one. And this point, x is 1/2. So we know f of 1/2 is the square root of e. So we know this is point. This is a fixed point. Then the corresponding slope is this one. So we have 1 minus this is equal to the slope multiplied by x minus 1/2. So we have this equation. Okay, number 5. Evaluate f of minus 2. F of minus 2, this is minus 2. If you try to draw a vertical line, then you can see we have two intersections. But the first one, this is a circle. So this is the function value, that is 4. First one. And the second one, x approaches negative 2. Negative 2 is here. When x approaches negative 2. Okay, this is a limiting value. When x approaches negative 2, we have to check the left side limit and the right side limit to see if they are equal to each other. So we can see left side limit and right side limit, the same point. So that means the limiting value exists. And the limiting value is just this one, which is 2. Which type of discontinuity at 0 and 5? 0 here and 5. 0 and 5, this is, you can see we have a jump here. There are two different points. And the yellow one is different from the blue one. The blue one is the actually yeah, the blue one is the first case, removable. Alright, then evaluate x approaches 0. When x approaches 0, we have to check the left side limit and the right side limit. The left side limit is this one, so it is 2. The right side limit is this one, it is 0. So that means they are not equal to each other. If the left side limit and the right side limit, they are not equal to each other, then you can just say DNE does not exist. 5e, 3 plus 3 is here. So 3 plus, that means the right direction. We have to use this one and then this direction. So you can see negative infinity. So we have negative infinity. Evaluate pi limit pi f of x minus 1. We can see the second term is a constant term, so does not change when x approaches infinity or negative infinity. And for the first term, pi is a constant number, so we can pull it out. Then we have this one. X approaches infinity. When x approaches infinity, we can see that is the positive 1. So this term is positive 1. It's pi minus 1. List the x values where the function is not differentiable. When the function is not differentiable, this is not the last question. We have one more question. Okay. So the first one, you can see this is smooth and continuous until this one. This is a jump. This is a removable. And then for this one, not differentiable. First point, second point. This is infinity. And the last case, this one. So we have these 4 points. And question number 6, this is the last one. Question number 6, consider this function. Horizontal asymptotes. Horizontal asymptotes just means the end behavior. That means what is the x approaches infinity f of x? And what about the x approaches negative infinity f of x? That is the horizontal asymptotes. So for the first case, x approaches infinity. This is the f of x. So we can see the trick is to divide it by the highest degree of the denominator, or just divide it by x, because this is x square. Square root of x squared is actually just x. Absolute value of x. So we divide it by absolute value of x. Then when pay attention, up to now, these two functions are the same. But when x approaches infinity and negative infinity, x divided by absolute value of x is different, because the denominator, absolute value of x is always positive, but for the numerator, when x approaches negative infinity, it's negative 1. When x approaches positive infinity, this term is positive 1. So that is the difference. And then for the denominator, it's just the same trick. So you can see we have these two values. True or false question. F has a vertical asymptote. This is the in-class activity. Show that it's non-negative. Because x squared is positive 1 plus a non-negative number. This one is always positive, so it cannot be equal to 0 for any x. Thanks for watching.